Welcome back to the GCSE Maths Pro YouTube channel. Today we're going to be looking at surd rules, and in particular, adding and subtracting surds. Make sure you go and check out the first video in this series, which is Simplifying Surds, because we're going to be using that in today's video as well. Our first question is 3 root 8 plus root 2. So the rule for adding and subtracting surds is basically the same thing in both cases. We cannot add two surds together if they are not the same. What I mean by that is, are the numbers inside the square root symbol the same? If they're not, we cannot combine them, we can't add them right now. The way that I remember this is it kind of works the same as algebra. If you think about it, if you have two different letters and you want to add them together, like x plus y, well, you can't simplify it any further, can you? You can't add them together, you can't literally put them together more than they already are, okay? Whereas if we had x plus x, for example, well, yeah, okay, they're both the same letter, so we can add them and it becomes 2x. How many have I got? One here, so there's 2 in total. So, what are we going to have to do in this case where we don't already have the same surds? We're going to need to simplify either both surds or just one of the surds. It depends on the question. And then hopefully after we've done that, we'll have two surds that are the same and we can go ahead and add them at the end. Here we can see, okay, can we simplify root 8? Well, if you've seen the previous video, you'll know that this is a pretty clear example that we can. So I'm going to run through this fairly quickly in terms of the simplifying process. So the 3 just stays on the outside. That's just telling you there's 3 lots of root 8, so that just stays there. And to simplify the surd, we want to split it into 2 square root symbols and 2 factors. So 2 factors of 8, obviously one of them has to be a square number, doesn't it? So the most obvious is going to be 4 times that by 2. That's where we get our 8 from. And the root 2 at the end, well, we can't simplify that any further. There are no square numbers, well, apart from 1, but again, as we mentioned before, that doesn't really make any difference. There are no other square numbers that would go into 2, so the other root 2, you're just going to have to keep writing it at the end there for now. Okay, we're going to simplify the square root 4, because obviously that would become 2. I'm writing it in brackets because that means multiply. Okay, and keep the other root 2 at the end. So we've got 3 times 2 times root 2. So the 3 and the 2 at the start are obviously both whole numbers, so we can just literally multiply those. That gives you 6. The root 2 stays there, plus another root 2. So you can see now that we've simplified one of the surds. We've ended up with 2 surds that are the same, i.e. root 2 and root 2. Now we can actually add them. But how do we then go about adding them? Well, again, I refer back to algebra. How would you add, if you copy the same example, how would you add 6x plus x? Adding and subtracting is just kind of counting how many there are, isn't there? Now, x is technically 1x, isn't it? There's an imaginary 1 there. And that's the same with if you've just got root something. There is technically an imaginary 1 in front of it. So I've got 6 root 2's over here, so 6 lots of them over here, 1 lot over here on the other side. If I add them together, I'm just saying, right, 6 plus 1, basically, isn't it? So I've got 7, and then you just put the root 2 afterwards, exactly the same as algebra. Here, you'd get 7x, wouldn't you? So a lot of people kind of think that there has to be something that changes with the root 2's. It's not. The root 2 is still the same. It's still the format of root 2, but we're just saying on the outside of that, how many of them do we have? We've got 6, we've got 1, add them together, 7 in total. They're still root 2. The root 2 itself hasn't changed, okay? So that's how you'd add surds. The same with subtracting. Go through the same process, simplify whatever you can simplify out of the 2 surds, and then subtract at the end. So we're focusing on adding or subtracting the numbers that are on the outside of the surds. Let's look at another example. Okay, so we've got 2 root 50 plus 5 root 32. Again, can't add them straight away. So let's see what we could simplify. So what square number factor goes into 50? Obviously 25. We need to multiply that by 2 to get back to 50. So I've got 2 times root 25 times root 2. And on the other side, just put the 5 there. What square number factor goes into 32? Well, that would be 16. Now, if you've already simplified one of them and you need to simplify the other one, because we know that we can only add or subtract surds that are the same, if you know that this root 2 here is going to be the surd that's left behind, it kind of gives you a bit of a hint for the second one, doesn't it? Because we know they're going to have to be the same at the end. We're obviously looking for them both to be factors of 2 and the square numbers that multiply with those. Okay, so I'm going to whiz through that again. Square root of the 25 is obviously going to be 5. And square root of the 16 gives me 4. Again, all of these are just multiplied together. So 2 times 5 is 10, root 2 at the end, and 5 times 4 is 20, and again, root 2. So we've gone through the simplifying process. Now that they're both root 2, we can go ahead and add them. Like I said before, we're just adding the numbers on the outside. So we've got 10 lots of root 2 plus 20 lots of root 2. So in total, we have 30 lots of root 2. So it's still root 2, but there are now 30 in total. That is your final answer. Okay, next one. Again, now that we've gone through a couple, pause the video, try this one out yourself, and then play it when you're happy to have a look at the workings. So split it into two factors. The square number that's going to go into 63 is 9. What do we multiply that by? 7. So we've got root 9, root 7, plus 6, and then 2 square roots. Again, now this kind of gives you a hint. Okay, the leftover square root is going to be likely 7. Obviously, double check that that works. What do I times by 7 to get to 28? 4 is for a square number. Yes, in which case it works. Okay, so square root the 9, which is 3. We're left with root 7, obviously. 6, square root the 4, which is 2, left with another root 7. 2 times 3 is 6, so 6 root 7, plus 6 times 2 is 12, root 7. So we've simplified both of them. Now, adding them together, 6 plus 12 is 18, and root 7 is still left as your remainder. That is your final answer for this one. Okay, so this is still the same thing, but I just wanted to show you that they could, or more likely are going to word it like this in your exam. So it says express root 3 plus root 12 in the form a root 3, where a is an integer. Now, effectively, it's just saying add these two together. But I think a lot of people will get thrown by the wording of the question. Just focus on this, just add them together to start with. And then all they're saying here is actually a bit of a clue here, a bit of a hint, is that the remaining surd is going to be root 3. So as you can see, obviously the first one's already root 3. Can't simplify that any further. But the root 12 we could simplify, and it just gives you a bit of a hint as to, okay, it's going to be 3 times something, 3 times another square number. When they have bigger numbers, it will at least give you a bit of a guide. The last bit that says where a is an integer, so an integer just means a whole number, right? So you're not going to have like, I don't know, 1.5 root 3, right? It's going to just be a whole number. So this is exactly the same question. They've just worded it in a more specific way. So what we're going to do is I'm just going to copy it down here. What can we simplify? Obviously, like we said before, we can't simplify the root 3, but we can simplify the root 12. And as we know, one of those factors is going to have to be 3. And obviously, the square number that goes with it is 4. 4 times 3 is 12. So root 3 stays there. Square root the 4, which becomes 2, and root 3. Add them together. Again, remember that there is technically an imaginary 1 in front of the other root 3. So we've got 1 here and 2 on the right. Add them together is 3 root 3 in total. A is obviously the 3 in the front, right? A is this integer here. Right, so we're going to do exactly the same thing, but now we have subtract. So literally go through the same process, simplify one or both of the surds, whatever you can do, and then just subtract the numbers in the front rather than adding them. So feel free to pause the video, try this one yourself, and then we'll go through it together. All right, so 80, what square number factor goes into 80? Well, 16, and that will be times by 5. 16 times 5 would give you 80. Now, because we already know that the root 5 is what's going to be left over, that gives me a clue for my second surd when I simplify it. That's going to have to also be 5. And then what do we times by 5 to get to 20? 4, which is obviously also a square number. Okay, square root the 16, which gives you 4, root 5. Square root the 4, which gives you 2, root 5. Now, 4 times 5 is 20, root 5, and then you've got minus 2 root 5. So now we just subtract, again, just subtract the numbers in the front as if you had, for example, 20x minus 2x. You're going to get 18x. It's still x, but there's now 18 of them. So here we've got 18 root 5. The root 5, it hasn't cancelled out. Nothing has changed about the root 5. We're just saying how many do we have? 20 over here, take away another 2 is 18. Okay, pause the video, try this one out, and then we'll go through it together. So 4 and then 27. What can we split that into? What square number goes into 27 is obviously going to be 9, and then therefore 3 minus root 75. Like we said before, we've got a bit of a clue. That's going to have to be 3. So what square number times by 3 gets to 75? It is 25. Okay, go through and square root what you can. So square root the 9 to get 3. Square root the 25 to get 5, and multiply if you've got both terms or just one of them, multiply whatever's in the brackets. So 4 times 3 is 12 root 3 minus 5 root 3. So how many do we have in total? 12 root 3 minus 5 root 3 is 7 root 3. Again, pause the video, try this one out yourself, and then check if you've got the same answer that we get. So 200, well, we've got 100, which is a square number, and we have to multiply it by 2, minus 3 root 8, and root 8 we need to write it out just so we don't get mixed up. So we've got 4 times 2 is 8. Okay, square root the 100 is 10, root 2, minus 3 times the square root of 4 is 2, and then root 2. Multiply anything that you need to multiply, so the 10 root 2 is fine, 3 times 2 is 6 root 2, if we subtract, 10 minus 6 is 4 root 2. Okay, this is our last question. Again, I've written it in the same format that you might see it in an exam. So don't get thrown if they write it like this. It just means do this calculation here, subtract these two surds, and you should end up with this format. Now with this one, it's again quite handy to know that the surd that will get left over is root 6, because I think 96 might be quite a tricky one, especially if you don't have a calculator maybe, to figure out what goes into it. It gives us a bit of a clue. We can do 96 divided by 6 to find out. It's actually going to be 16. So 96 is going to be split into 16 and 6. And we obviously know, therefore, that the second surd must also split into a square number and 6. So obviously 6 times 4 is 24. Okay, square root the 16, which is 4, root 6, square root the 4, which is 2, root 6, and subtract them to get 2 root 6 left. So it says in the form a root 6, where a is an integer, obviously again a is that 2, isn't it? A is just the whole number that goes in front of the surd. Okay, so that is the whole of adding and subtracting surds. So you can see here, of the whole surd topic, we've done simplifying surds, we've now done the adding and subtracting surds. The next video in this series is multiplying and dividing surds, so make sure to check that out next. Subscribe to the channel, comment down below if you have any questions, and I will try my best to get back to you.